Trig 6. Trig 6 is talking about special right triangles. This happens to be a very large concept of almost everything we do with trig this year and next year in pre-calc. And our special triangles are 45, 45, 90, and 30, 60, 90. All right, when it comes to the 45, 45 degrees, because the angles are the same, so are the leg measurements, and the hypotenuse is always across from the 90. So when I set up this relationship and I ever see a 45-degree triangle, I know the legs are equal to one another. When it comes to the hypotenuse, it has a special relationship that it is leg times root 2. And the reason for that is because if I were to prove this with a Pythagorean theorem, I would say leg squared plus leg squared is hypotenuse squared. Well, this is 2 leg squareds. Now when I square root both sides, I can take the square root of L squared and get L, but I can't take the square root of 2. And the square root of a square is itself. So that's why the hypotenuse is leg root 2, because I can prove it with Pythagorean theorem. But as long as I remember this relationship, you won't have to prove it again. All right, so let's look at a quick example of this. If I tell you that triangle has a measurement of 6, what you would need to know is that these little slashes from geometry, hopefully, we remember that when you have the same slashes, it means they're the same measurement. So you could find the other sides by knowing this relationship. This is going to be a side measurement of 6 because it's marked the same, therefore it is the same. Because these are the same, it's a 45, 45. Therefore the hypotenuse is the leg times root 2. 6 root 2. You could do Pythagorean theorem, but you don't have to because we've already proved that. All right, so let's try another one. Okay, so if I give you this triangle, again, because the sides are marked, it means it's a 45, 45, and I'm giving you the hypotenuse. I know the hypotenuse is the leg root 2. So I can set that 10 root 2 is the leg root 2, divide by the root 2, so the legs must be 10. Or knowing that this is leg root 2, you can just look at it and say 10. When it comes to these 45, 45, 90s, and then soon here the 30, 60, 90s, if you know the relationship, you do not have to show the work, like the proving or the work here. You can just go straight forward and answer the triangle. All right, so on a 30, 60, 90 triangle, they're not the same, but the sides are related. 30 is considered to be across from the short side because the short side always has the smallest angle, or the smallest side, smallest angle. Across from the 90 is always the hypotenuse, and so that we make 60 the long side. All right. When it comes to a 30, 60, 90, the hypotenuse is always twice the short side. That relationship will always be true in a 30, 60, 90. The long side is always the short times root 3. That relationship will always remain true. Okay, so let's look at a picture. Here's a 90-degree triangle. The 30 degrees, 14 is the hypotenuse because it's across from the 90. So that means my short side, which is across from the 30, is half, because if I look here, the hypotenuse is twice the short. So if the 14 is the hypotenuse, then the short side must be half, which is 7. Now the long side, that must be this other one, because by angle sum property, this must be the 60, which makes that the long side. The long side is the short root 3. The short side is 7. So it must be 7 root 3. All right, let's try another one. There's my 90. There's my 60. And across from the 60 is 5 root 3. So if you're asked to find the other sides, we know the long side is the short root 3. So 5 root 3 equals the short root 3. Divide by the root 3. So the short side, which is this other angle, must be 5. Now we know the hypotenuse is twice the short, so twice times the 5 gives us 10. Once you know those properties and you have this memorized, and you need to memorize it because you are going to do tons and tons of work with that this year and next year, you need to really, really be clear on what it is to be a 45-45-90 and a 30-60-90. And that's trig 6.